So you एक काम करो वो उठाओ उठा लो बैठ जाओ बैठ जाओ that is an object its shape is cylinder now pure rotation मतलब pure दो टर्म pure translation and rotation and rotation. Now in this chapter we will talk of extended objects. Extended object means which have dimension, which are not point masses. Okay, it has a dimension. It could be either, and it could be in one dimension, two dimension, three dimension. Doesn't matter. It should have dimension. Okay, basically non-point masses. Before this chapter, everything you could consider as a point mass, and it won't matter. But in this chapter, you won't consider it as a point mass. That means there is more than one point. One point. Basically, it is more than one point. Fine. The moment it becomes more than one point, it becomes a non. You can say it has some dimension. Okay. Now think about this. If he just this is a block of mass and he's sliding on the floor. Okay, just sliding. This is called pure translation. Okay, pure translation. How do we identify pure translation? Is this is very important. Listen to this. Okay, you take any two random points on the object. Any two random points in the object, they are not moving with respect to each other. They are not moving with respect to each other. Okay, fine. If you take a point A on the object, point B on the object, and they are not moving with respect to each other, then it is a pure translation. Also, they should follow for all points. It's not like for you have taken 2 points and this thing is following, but for another two set of points it is not following. No, it should follow for every set of 2 points. Okay, fine. Okay, have you understood what is pure translation? Okay. See, now there is something called rotation. Pure rotation. What is pure rotation? That fan is doing the pure rotation. Okay, fan is doing a pure rotation. How do you identify pure rotation? To identify pure rotation, you should understand that one point will be stationary. One point will be, it's not even one point, there's a set of some points will be stationary and that will be fixed, and some point and all the other points will be moving. Okay, so for example, if you take a pencil, you insert it in the center. Okay, and now you rotate the cylinder about it. Yes, about the pencil. In this case, your pencil is also moving. So you hold the pencil. Yes. Okay. Understood? Have you understood? This is called pure rotation. Okay. Understood pure rotation. Pure rotation means the pen, the line, imaginary line, which is passing through the pink pen, is called the, what do we call it? Axis of rotation. Yes. It is called axis of rotation. Understood? This is called pure ruling. Pure translation. Pure rotation. Pure rotation. Now there is something called translation plus rotation. Or translation plus rotation. Pure rotation. So this is rotation and it is also translation. Understood? Has anyone understood? This is called translation plus rotation. Now I will give you questions. I'll ask you few scenarios. You have to tell me whether it is pure translation, pure rotational, or translation plus rotation. Okay. A bicycle is moving its tire. A bicycle is moving its tire is performing what? Harshal, you can also answer. Dhoni, you cannot. Yes, you also can. Pure translation. Huh? Pure translation. टायर है ना
प्योर रोटेशन
वो है ना कैसे what is stationary क्या किसमें टायर में मेरे प्लेन स्टेशनरी इसमें प्योर ट्रांसलेशन प्लस प्योर रोटेशन में कुछ भी स्टेशनरी नहीं पेन भी तो मूव कर रहा है राइट में, राइट। तो इसका आंसर क्या है? बोथ है ना? किसी को डाउट तो नहीं इसमें? नहीं ना? A car is going, its tire is both, but the driver is pure translation, right? ठीक है ना? Okay. Have you guys understood this? Wings of a turbine blade. Pure rotational. ठीक है. Okay. Okay. Now there is one thing. Axis of rotation लिखा तुमने क्या? अब नोट में ना जितना तुमको समझ में आया लिखो. अभी तक जितना समझ में आया जल्दी से लिखो. रोटेशनल मैंने सब ला दिया. विक्रम कहाँ से सुनना शुरू किया?
सर वो पेन और वो सिलेंडर से.
प्योर ट्रांसलेशन समझ में आ गया? प्योर ट्रांसलेशन, प्योर रूलिंग,
हाँ.
प्योर रोटेशनल और ट्रांसलेशन बोथ. ठीक है. Pure rotational translation. It's neither pure. It is neither pure translation nor pure rotational. It's both. It's both. अब प्योर नहीं है दोनों, दोनों का मिक्स है. रोटेशनल. हाँ. ठीक है बच्चों, लिख लिया है? लिखो लिखो थोड़ा सा. 1 more minute. ग्रेविटेशन तो नहीं है ना? Is this the old book? न्यू बुक. और इसमें तुमने कहां तक बोला? कहां तक है? 92 to 100. 92 to 100. मजा आएगा. Watch rotational. Yes, it is pure rotation. Watch clock. ठीक है. A jet plane cruising. No, it's a jet plane cruising is pure translation, right? A lattu spinning in one position at one place. That's only rotation. Only rotation. What?
So what about speedometer?
Speedometer.
Yeah.
Speedometer. Speedometer मतलब वो what? I don't understand your device. That
No, like be rotating right the kilometers and it keeps changing.
क्या बोल रहा है? नहीं समझ में आया.
See,
फिर से बोलो.
so like see when you accelerate in the car, the speedometer changes its reading now, not the digital one, the analog kind.
And there.
The pure rotational, right?
Oh, the pointer of the speedometer.
Yeah.
You know, it is not pure rotational. The car is moving forward, no?
Yeah. Okay, fine.
It is rotating. If you, with respect to the observer in the car, it is doing a pure rotation. Good question. जैसे मान लो ना एक स्पीडोमीटर है जैसे घूम रहा है, ठीक है, इन द कार. मैं बोल रहा हूँ ऐसे घूम रहा है. एक क्लॉक है जो कार में रखी है, ठीक है. तो with respect to observer in the car, this clock is doing what? This is a good example. Yes, if a clock is kept in a car, with respect to someone in the car, the clock is doing pure rotation, right? But with respect to someone outside, out the car, and the car is moving, of course, then it is doing pure rotation plus, sorry, translation plus rotation. So of course these ये जो जितने भी motions है ना, whether it is pure translation or pure rotation or these are observer based. Okay, ये लिख लेना important point. These are observer based. Observer change हो जाएगा और you will ठीक है. जैसे फॉर एग्जांपल इसको देखो उधर तो मतलब वो जो उसको फिर से ट्रांसलेशन और रोटेशन करो. So this वो वाला करना है, दोनों वाला जो है, ठीक है. So this motion is pure translation plus rotation both, ठीक है. For me, for you, right, for Soham. But if imagine if there is an ant which is sitting on the pen itself. There is an ant which is sitting on the pen itself. Then for that ant, this motion will be
translation. Because it's moving.
what is the speed of this? Suppose this object, cylinder object, is going with 5 meters per second. Pure rotation, right? Pure rotation. For the ant, yes. Think about it. If the ant is on the axis of rotation, it is not rotating. Anything which is on the axis of rotation is not going in circles, right? So it is not going in circles. It is just staying in one point. But the whole object is moving to the right. So the speed of the ant is same as the speed of the object. So ant will see the object as rest, but rotating. Understood, right? This example also. Make this maybe right. Online people, have you understood this? Very good. लिखो जल्दी.
Sir, how will you put it in a sentence? Like, how do I form a sentence?
Class 101 of Communication and Language. Welcome to paragraph composition. You make the diagram, okay? Make the diagram of that thing, cylinder, and then show that it is revolving and going forward as well. And then say an observer or mark a point on the axis of rotation and then say with respect to this point, the cylinder is only doing rotational. You all have written? Okay, now open your book. You all have books, NCERT books. In the first page, second page, third page, fourth page. Okay. Everywhere you see there is something written in bold, you write a statement. Okay. NCERT book kholo, first page, first 4 pages, whatever is written in bold, copy paste that. We will see what is written. Okay. पहला बोल्ड लाइन क्या लिखा है?
Ideally, a rigid body is a body with perfectly definite and unchanging shape. The distance between all pairs of particles of such a body do not change.
लिख लो. All this discussion is only for rigid bodies. Write the definition of rigid body. Okay. You have written. What's the next black thing written? Yeah, okay. Well, you have understood what is a rigid body. Rigid body is something in which you take any two set of points, they don't change. Okay. If you take a sponge, okay, suppose there is a sponge. This, let's say this mouse is a sponge. This mouse is a rigid body. Okay. And what happens if you take any 2 points? The distance between them does not change with time. Okay, any 2 points. Okay, but if this cloth is not a rigid body, so at this point, these 2 points are some distance, and now they are not. Fine. So this is not a rigid body. Okay. Will a spring be a rigid body? No, it is not a rigid body. Fine. Okay. Okay. Next is what is the next black thing written?
Rigid body which is not limited of its some translation or combination of translation and location. Motion of rigid body which is not which is pivoted or fixed in some ways location. After that is simple.
So it is written that motion of a rigid body which is not pivoted about some point. Not pivoted का मतलब pivot का मतलब ये होता है if I am rotating this pen, okay, about this. If I am rotating this pen, this is the point of pivot. This is the point of pivot. If that is door is rotating about उसका pivot point क्या है रोड का? Hinge. Very simple. Okay. Okay. Fine, everyone. So you understood if the object is not pivoted, then it will either go translation or translation plus rotation. So if I if I throw this pen at you, okay, throwing like this, I'll try to do it in pure translation. Okay, I tried to do, but still rotated. Okay, if you just throw it like this, it will do more rotation. Understood? So if you throw something like this, it will rotate also, and it will go a projectile also. So that projectile motion is the translation motion. Okay, and that rotation which is doing is the rotation. Right? So if it is not, so I'll repeat the statement. If the object is not pivoted, that will either do a pure translation or mix of translation and rotation. Easy. And if it is pivoted, then it will pure rotation. ऐसा बोला है क्या? ऐसा बोला है क्या उसमें? Pivoted about a fixed point, no? ठीक है. Then that fixed point is not moving. हाँ, ठीक है. Then it is okay. Okay. You have to understand that if it is pivoted and that fixed point is not moving, that is a fixed point, then it is pure rotation, right? And that point is also moving, right? Then it is translation plus rotation about a fixed point. Okay, understood? Take. What is the next black thing? Have you written this black thing? Take. What is the next black thing written? Was direct 4 कभी यहाँ पे कुछ लिखा हुआ है बीच में.
In the translation motion at any instant of time, all particles of the body have same velocity.
Yeah, in pure translation, right? Any 2 points will have same velocity. A more basic statement is the relative velocity of any 2 point is 0. The velocity is same, and therefore the relative velocity is 0. Write this. Clear? Next statement.
Body about its axis, every particle of the body moves in a circle which lies in a plane perpendicular to the axis and has its center of the axis.
Too much. Slowly.
In rotation of a rigid body,
One second. I'll repeat for them also. Okay. In rotation of a rigid body
about a fixed axis,
about a fixed axis,
every particle of the body moves in a
every
circle
particle of the body moves in a circle
which lies in a plane perpendicular to the axis
to the axis
and has its center of the axis.
and
has its center on the axis.
Has its center of the axis.
On the axis.
Has its center on the axis and has its center center on the axis. Okay, good, good. Understood. Understood. Now I have understood. See. Start drawing. Okay. Got it. So, you understand XYZ plane, no? Planes, no? Okay. Integration. So if this is x-axis, this is y-axis, this is x. No, उल्टा हो गया. Sorry. ये y है, ये z है, ठीक है? Because x cross y कुछ should be z, तो ऐसा नहीं कर सकते इसको y करके इसको z नहीं कर सकते, ठीक है? क्योंकि अगर इसको x किया, इसको y किया, तो z ये हो जाता है, ठीक है? x cross y should be z. Basic mistake नहीं करनी चाहिए, ठीक? Now let there be a square. Think about this. Let there be a square in the xz plane. Okay. एक square lamina है, मतलब एक notebook पड़ी है basically. एक notebook पड़ी है in the. So this is a notebook in the xz plane. Do you understand this? Everyone. ठीक है? Okay. Now. Let's say this notebook is fixed about a nail which is in the y-axis. Okay. Let's say this notebook is fixed in. There is a nail which is fixed, okay, and in the y-axis. And this notebook is rotating in the xyz plane, right? Notebook is rotating in xy plane. So at this moment, the notebook is looking like this. After some point, it might look like this, right? After some point, it might look like this, but it will always stay in this plane. You understand? Right?
Like this.
Yes. Yes. Okay. Let us try to ask some questions so that you have understood the motion or not. Tell me, let's say this square notebook of side A, what is this point, corner? A comma 0 comma 0, and this corner comma 0 0 पे y पे कितना है? अच्छा x पे अरे a comma 0 comma a है ना, इतना दिमाग क्यों लगा रहा है? कोऑर्डिनेट तो a comma 0 comma a है, right? And this coordinate 0 comma 0 comma a. Good. Has everyone understood this? I am calling these points as a, b, and c. Okay, and there is also point d. Now, what is the distance of? देखो, axis of rotation क्या होता है? Axis of rotation is imaginary line. Axis of rotation is imaginary line passing through pivot. Okay. Axis of rotation is imaginary line passing through pivot. But देखो, is this line passing through pivot? I have drawn this. Yes. Y-axis is the line passing through pivot, right? Is this line also passing through pivot? अबे दिख नहीं रहा pivot. Pivot ये point है ना D. Pivot is the point D. Everyone understood, no? So this line is also passing through pivot. All these lines are passing through pivot, right? So just defining that line which is passing through pivot is not axis of rotation. Out of these, which are axis of rotation? Only this is. Well, these are not, right? So it is also, we also write one more thing. It is perpendicular to plane of rotation. It is perpendicular to, अरे चला गया क्या? Sorry, रुको. Yeah. The plane of rotation in this case is which plane? अरे एक्स वाई प्लेन क्यों लिख दिया मैंने? गलत लिखा था ना, ये गलत लिखा था ना, एग्जैक्ट था वो. तुम लोग ने एक्स वाई लिख लिया क्या? देखो नोटबुक इज रोटेटिंग एग्जैक्ट प्लेन है ये. So what is the plane of rotation? Exact plane. Okay, fine. This is the exact plane. Okay, if this rotates, the D point will stay there. It will not moving, right? Point D is not moving. Okay, now describe the motion of point C. Yeah, good. It is undergoing what? What kind of motion? फिर rotation. और इसका अच्छा नाम और है क्या? और सिंपलर नाम है क्या जो पहले पढ़ चुके हैं? सर्कुलर नो, इट इज. हाँ, अभी तक ये मैंने बोला नहीं कि इट इज रोटेटिंग द कांस्टेंट एंगुलर ओमेगा. और अगर मैं बोल दूं इट इज रोटेटिंग विद कांस्टेंट एंगुलर ओमेगा, देन पॉइंट सी विल डू UCM. Okay, so if this notebook is rotating with constant omega, everyone knows omega, or you don't know omega? You know omega. Omega everyone knows, angular velocity. If this is rotating with constant angular velocity, now I'm saying, okay, this is condition है ये, ठीक है? It could not be revolving with constant angular velocity, but I'm saying it is revolving with constant omega. Then point C will undergo what? UCM. अच्छा, अगर if something is undergoing UCM, then उसका एक रेडियस होगा और उसका एक सेंटर होगा. उसका रेडियस कितना है? रेडियस कितना है? A, और सेंटर क्या है? D, राइट? समझ में आ रहा है ना? ठीक. What about point A? Is point A also doing UCM? Yes. उसका रेडियस कितना है? A. उसका सेंटर कितना है? D. What about point B? वो भी UCM है? Yes. उसका रेडियस कितना है? A root 2. The square of side A. So the diagonal is A root 2, right? So it is A root 2. Has everyone understood this? What is the center? D. If you take any point on this square lamin, on square plate, it R might be different, but the center is same, D, right? Okay. And also understand that the D is a point. Axis of rotation क्या है इस केस में? No, axis of rotation is a line, is a y-axis. So here the axis of rotation is, I write that, okay? इसको मैं AR बोलूंगा, which is called axis of rotation. Is y-axis. It's always a line, okay? And POR मतलब point of rotation. Point of rotation. उसमें लिखो that is point. मतलब इसमें वो, what is POR? Point of rotation. Point of rotation is D, okay? Here POR always lies on AOR. POR will always lie on AOR, okay? क्या? POR, point of rotation. Yeah, point about which it is rotating, okay? A more correct way of saying. Online people, have you understood? Vikramaditya? ठीक है? Okay, now you read that black statement again. What's happening? Done? ठीक है. Next black statement.
Point of contact of top with ground is fixed. Movement around vertical is for precision. Only one point is fixed.
Okay, so suppose you have a top. So when you play a top, when you rotate a top, okay, you throw it, you wrap a thread, you throw it. Okay, what does it do? Some tops, you sometimes you might be able to make the top go in a vertical line. So it is just vertically standing, but it is rotating. Okay, but sometimes what happens, I hope ये diagram मैंने बताना सही बनाया कि नहीं. यही बनाया. In this case, there are two things which are happening. First thing is that ये वाला जो motion, the previous motion which was there, the rotation is happening, right? But there is one more thing which is happening, that this line is slowly rotating. This line is becoming like this, like this, like this, like this, like this. Okay, so it is going around in a cone, right? क्या बोला है वे कि this motion is called, क्या इसका नाम क्या बोला? ये precision, spelling सही है? ठीक है. So this, okay.
Movement of axis of top around vertical is for precision.
Movement of axis of top, right? So when they say axis of top, this is this line. Okay, this line, the motion of this line, okay, around the ground. So this line will, if you see my video, this line will go like this. Something else also does this, another object, can't call it an object though, because it's a feminine creature, but it goes around like this also and rotates also. Yes, Earth. Okay, Earth also does this. There is an axis of rotation. That axis of rotation is also revolving around the sun. Okay, fine. Yeah, understood everyone? Okay. उसके बाद क्या लिखा है? Black line. Good, Jayan, Jyotiraditya.
Motion of rigid body which is not limited or fixed in some way is either pure translation of a translation.
So we have read, no? Did this one? That's it. Okay. Okay. Now, अब क्या करो? अब देखो, अब एक सेंटर ऑफ मास कॉन्सेप्ट है ना. सेंटर ऑफ मास इज वेरी इजी कॉन्सेप्ट. ठीक है. उसका कुछ डेफिनेशन लिखा है क्या? ब्लैक लाइन से कुछ लिखा होगा? नहीं लिखा है.
The central mass of the system of particles.
नहीं लिखा है.
Center of mass of the system of particles moves as if all the mass of the system was concentrated at the center of mass and all the external forces were applied at that point.
तो CM देखो क्या होता है. Suppose there is a rod of length L, okay, and in this it is uniform also. Uniform means the mass is distributed uniformly over it. So when I say uniform, if you take half of the length, what is the mass of that half of length? M by 2. If you take any m by anywhere, if you take m by 2, यहाँ से यहाँ तक half length लोगे तो उसमें mass m by 2 आएगा. ठीक है, मतलब समझ में आया ना, डेंसिटी, mass density same everywhere. Okay, so when you say uniform, then you can say that if you take length x, the mass of that is nothing but x by L into capital M, right? If you take a length L of this rod, if you take a length x of this rod, okay, the mass of that mass of small mass of x is equal to x by L into capital L. Yes or no? Are you getting this? This is the meaning of uniform. Now, where is the center of mass? It is at L by 2 from the either end. Okay. What is the meaning of center of mass? Is that right? The entire mass of that rod, can be thought of as a point, as a point object of mass capital M at O, situated at O. मैंने डायग्राम में O बना दिया है, ठीक है, तुम डायग्राम में O बना देना.
What is the point object of
mass M, capital M, situated at O.
Can you repeat the statement?
The center of mass means that at that point at which the entire mass of the rod can be thought to exist, or can be, it is there at that point. So it's a point O. Okay, मैं कुछ तो गलत बोल रहा हूँ पता नहीं, but you understand my point, right? We can think of the whole mass of the rod. Rod is an extended object, but we can take it to be a point mass of capital M, and that mass is kept where? At O. That point O will be called center of mass. Now I have not explained to you what is the meaning of thought as, right? Physics wise thought as तो कुछ नहीं होता ना. Thought as का मतलब होता है you can apply the Newton's second law of motion. लिख लो thought as का meaning, मतलब what is that? Meaning is thought as मतलब you can apply Newton's second law of motion on that. Okay, an example is, let's say this is a rod, okay, a big rod, and you are trying to pull it like this. Okay, so now, till now, very important point, till now you are not asking at which point the force is applied. You are only asking on which object the force is applied, right? So for example, you were doing blocks per force, right? And let's say there was a block which was, you were doing pulley questions, right? ऐसे कर रहे थे तुम pulley questions, or you were doing block questions, right? ऐसे block question तुम कर रहे हो या फिर pulley question कर रहे हो, anything. Okay, let's say I ask you, there is one force which is acting on both of these, which is the basic force. कौन सा है? mg, right? Okay, एक तो gravity force है, जैसे दोनों पे लग रहा है gravity, ठीक है, और एक और मान लो इस पे लग रहा है, एक नॉर्मल लग रहा है ना, उस पे टेंशन लग रहा है, ठीक. अब देखो इंपॉर्टेंट पॉइंट ये सुनो, ये ऑब्जेक्ट एक्चुअली पॉइंट मासेस तो नहीं थे, they were not point masses, they were actually big blocks of masses, right? So let's say this is the big block of mass. This big block of mass means it has mass everywhere, right? Okay, so there is a molecule here also, there is a molecule here also. Gravity will not pick and choose, it will attract this also, right? So the force of gravity, is it acting at a point? Is it acting at one point? No, it is acting at every mass, right? Yes or no? Every small mass it is acting. So it is acting at how many points? Infinite points. It is acting at infinite points. And if the volume of that, the volume of that points is total LBH, the volume of this cube, right? Everywhere inside that volume there is a mass, and the gravity is acting on that mass. If this was, let's say, a hollow cube, hollow means it is only mass sirf outside में box है, तो gravity would act on the lines also, the lines नहीं, the surface area, right? All the points which are on the surface area, right? ठीक. But we still show the mg to be at one point, right? Which we don't say. See, also understand. Let's say there is M1 and M2. दोनों पे force नीचे की तरफ कितना है? M1G और M2G, right? And there are, let's say, small masses M1, M2, M3, M4, and there are infinite masses. If you add all those masses, M1 plus M2 plus M3, you'll get the total mass of the block, which is small m, right? You'll get the total mass of the block, small m, and that we say it is acting. यहाँ पे दोनों में क्या बोलते हैं? It is acting at the center of mass. Okay, so what you're doing is you're applying Newton's second law. You're saying the sum of all applied forces. While for doing FBD, what you're saying that the gravity is acting on the center of mass. Center of mass mostly is geometrical center only, mostly. Okay, so if it's a cube, uniform cube, then the center of mass will be at its it's a cube, the center of mass is where? At the center. How is the center defined?
All equal distance from all sides.
Equal distance from? Correct. Or intersection of the body diagonals. Intersection of the body diagonals. Okay? Okay. Have you understood this? You should also understand, इसमें जो normal है ना, जो normal force है, that is not acting on the center of mass. वो कहाँ है? Normal किसकी वजह से? Because of which force is it acting? Touching the ground, right? So it normal is acting on which points? The bottom surface. It is only acting on the bottom surface, right? Do you understand that if this was a block, the normal would only act on the this area? Have you understood? And now this where the force is acting will play a role. Okay, in this chapter you have to be very careful due to what the force is acting and therefore at which point the force is acting. What about tension? Yes, tension acts at one point, exactly one point, right? Because tension मतलब क्या? String जुड़ा हुआ है ना block से, तो tension किस point पे act कर रहा है? सिर्फ उसी point पे जहां से जुड़ा हुआ है. Understood? Are you understanding this? The point of application of tension is a single point, right? Write this. Point of application of tension is a single point. Point of application of normal is a surface area, is a square, right? If it's a cube, it's a square of area. How much area? If it's a cube of side A, normal is acting on surface area A square. Are you getting this, everyone? हर्षल समझ में आया कि नहीं आया? देख रहा है ऐसे विक्रम? ओके, ध्वनि? कृष्णा अर्जुन? Yeah, okay. mg is acting on the whole body, right? It's acting on a volume. Have you guys understood? ठीक है, okay. So in this case, if ये जो rod बनाया है तुमने, इसके पास में लिखो, if a man was pulling this to the right, ठीक है, and he is applying a force at point A, so this is my point A, okay. Okay. Then while
Sir, I'll be back in a second, okay?
I'll take a 5 minutes break, okay? It's 11:10. हाँ, इस वीक रख दूं क्या? एक मिनट कॉल करके फिर मैं टेस्ट शेड्यूल करता हूँ. The mathematical formula of center of mass is this. The x center of mass is m1 x1 plus m2 x2 plus m3 x3 plus by m1 plus m2 plus m3 plus. Okay, write this quickly formula. Okay, it is also written as sigma mi xi by sigma of mi. Okay, keep on writing. It is also this integral dm, integral क्या था नहीं, integral x dm, integral x dm by integral dm. It is also this. Okay. And the ycom is m1 y1 plus m2 y2 plus m3 y3 plus by m1 plus m2 plus. These are not different formulas. They are just you're replacing x by y. Okay, that's it. It is also given by sigma mi yi divided by sigma mi. It is also given by integral y dm by integral dm. Similarly, there is a z also. No need. Okay. देखो, how do you, what is the meaning of this equation? Suppose there is a rod, okay, of and it is lying on the x-axis. This is the x-axis. This point is x equal to 0. The length of the rod is L. So this coordinate is L comma 0. This coordinate is 0 comma 0. Okay. And the one-dimensional rod, mass m. How do you determine the center of mass? You pick up any small mass. Okay. Let's say this mass. Okay. So you break the rod into small pieces. Okay. So let's say you take a small mass here. Sorry, you take a small mass here. Okay. And its small mass is, let's say, m1. Okay. ठीक है. अच्छा, ये यूनिफॉर्म रॉड है ना, तो मैं इसका तुमको डेरिवेशन ही I'll show. Okay, how is the derivation? A small mass, what you do is, sorry, you take a small length of this rod. Okay, small length. Let's say the length is dx. Say the length is dx. Small length dx. उसका मास कितना होगा? नहीं, dx by L into capital M. Okay, and because this is small mass, it is called dm. Okay, so dm is equal to small m by L dx. Yeah, are you getting this, everyone who's online? इसको अच्छे से लिख देते हैं, m by L into dx. dm. What is x center of mass? You go to a mass. Okay, you go see, understand this. What is the process of finding x center of mass? You go to a particular mass, ask what is the location of it, what is the x, multiply them. यहाँ देखो क्या लिखा है, m1 x1, m2 x2. So you go to a particular m1, ask its x1, let's say this x1, multiply it. Okay, you multiply it. So yeah, let's say this is at a length x. Okay, length x, at a length x. Okay, you will say that for that the mass, small mass, into the length x, right? ये ना देख, mass of that object into where it is x. So mass of the object कितना है, dm है, और कहाँ पर वो x पे है. अच्छा, by the way, if it was different, suppose you take a different mass here. Okay, let's say it is dm2, it is x2. So you'll add plus dm2 x2, right? Plus, understand, for a dm3, different dm3 x3, you'll add dm3 x3, right? Adding repeated number of times is same as writing summation. Okay, and if it is continuous adding, not discrete. Discrete means you're adding in steps like frog. Okay, discrete, but it's not discrete, it is continuous. It means integration. ओके, इंटीग्रल dm इंटू एक्स बाई फॉर्मूला क्या था यहाँ पे, इंटीग्रल dm, ठीक है। Now what is the expression for dm? It is m by l dx और x, समझ में आया ना, इंटीग्रेशन डिवाइड बाय इंटीग्रेशन dm क्या है, dm is just m by l dx, yes or no? Without, if you didn't write integral dm like this नीचे वाला as m by l dx, see you can understand ये वाला जो m by l है, m by l is constant, right? It will come out, नीचे वाला देखो, नीचे वाला खाली m by l constant. What is the integration of dx? Dx is small length, or a sum of all small length, total length, which is l. So integral dx will be l kata, you will get what, m. You could have also said just logically, what is the sum of all small masses? This is dm, matlab small mass. This integration means sum. So the integration of all full sum masses is big mass. You understood the denominator, everyone? Write it. हाँ मैं बता रहा हूँ, न्यूमरेटर में m by l को बाहर करो तो अंदर क्या आएगा, इंटीग्रल x dx आएगा ना, करेक्ट। सो अंदर आएगा x स्क्वायर बाई टू, x गोज फ्रॉम, ग्रीन वाले x को देखो, ग्रीन वाला x टू कवर द एंटायर रॉड, पहले का x कितना है, if you want to cover the entire rod, x is equal to, x goes from 0 to cover the entire rod, पूरा रॉड चाहिए 0 to l, नो। सो इसका इंटीग्रेशन जो लिमिट होता है वो होता है 0 to l, यहाँ भी 0 to l ही था, ठीक है। तो इसमें आएगा m by l और x स्क्वायर बाई टू, और लिमिट कितनी आएगी, 0 to l। डालो, लिमिट डालना आता है ना, नहीं आता, लिमिट डालना नहीं आता, तो इसका ये होता है कि एक्स स्क्वायर बाई टू 0 to l, तो ये होता है x l स्क्वायर बाई टू माइनस 0 स्क्वायर बाई टू, बेसिकली ऊपर वाली माइनस नीचे वाली। तो जो न्यूमरेटर में आएगा, न्यूमरेटर में आएगा ये m by l into l square by 2. Are you getting this, everyone? There is an m by l which is outside, and integration of x dx will become x square by 2, which will become l square by 2. So guys, are you getting this or not? फाइनली कट कुटा के क्या आंसर आया, l by 2, ठीक है, समझ में आ गया। दिस इज यूनिफॉर्म रॉड, ठीक है। एक और क्वेश्चन करते हैं जिसमें ये रॉड यूनिफॉर्म नहीं है, इसमें रॉड यूनिफॉर्म नहीं है। लेट्स से, जल्दी जल्दी लिख लिया है, फटाफट लिख लिया सबने, हटा रहा हूं, जल्दी लिखो। सॉरी, ठीक है, ओके नेक्स्ट लिखो। लेट्स से देयर इज अ रॉड ऑफ linear mass density lambda is equal to m by l, कैसे करते हैं भूल गया मैं, m by l x, m by l into x, ये लिखो। So lambda is a function of x, such that it is n by lx. क्या मतलब है इसका कि इसको गड़बड़ lambda naught x, lambda is equal to lambda naught x, where lambda equal to lambda naught x, where lambda naught is equal to capital M by n. ऐसे करेंगे क्या? At x equal to 0, lambda is 0. At x equal to L, lambda is equal to lambda naught L. तो देखते हैं, ठीक है? Okay, देखो, it is lambda x equal to lambda. What is the meaning of this? That if you take the rod, a linear mass density होता है. What is linear mass density? It is mass per unit length. So lambda is what? Mass per unit length. Mass per unit length. Okay, that is called linear mass density. ठीक है? So lambda is equal to lambda naught x. इसका मतलब क्या है? If suppose you know at this point x is equal to 0 and at this point x equal to L. Okay, write this quickly. This x equal to 0, x is equal to L. Now at x equal to 0, what is lambda? Lambda not into 0, so it is 0. Okay, at x equal to L, the lambda is equal to lambda not L. You will just put x values here and you are finding. इसका मतलब क्या है? इसका मतलब ये है, rod is very light on which side? Left side, and it is very heavy on the right side, and the density increases as you go from left to right. At L by 2, its lambda is lambda naught into L by 2, right? समझ में आ रहा है ये? एक्चुअली एक गलती कर दी है, यहाँ पे लैम्डा नॉट बाई एल होना चाहिए, मतलब लैम्डा नॉट बाई टोटल लेंथ होना चाहिए. सो यहाँ पे जीरो ही आएगा, यहाँ पे लैम्डा नॉट आएगा और यहाँ पे लैम्डा नॉट बाई 2 आएगा. उस क्वेश्चन में लैम्डा नॉट बाई, इसको लैम्डा नॉट बाई एल कर लो, ठीक है? डायमेंशंस मैच नहीं हो रहे थे. अब इस रॉड का सेंटर ऑफ मास निकालते हैं, ठीक है? So you say start by this argument that at a distance x you have a length dx. At a length x you have a small length dx. Okay. अब यहाँ पे इसका मास कितना होगा? हाँ होगा, तो मास होगा. मास क्या होता है देखो, मास इज लीनियर मास डेंसिटी. What is linear mass density? It is mass per unit length. So इसका मास होगा linear mass density into the length of this. इसका linear mass density कितना है? यहाँ पे कितना डिस्टेंस पे है ये? x. तो इसका linear mass density कितना है? देख, ये फंक्शन है ना linear mass density का, into x, right? It is lambda naught by L into x. This is the linear mass density. और इसका लेंथ कितना है इस पार्टिकल का? इस पार्टिकल का, इसका dx. This is the dm of this. फिर से देख लो, this is linear mass density and this is length and this is mass. Mass of this small pink element is linear mass density into length. Fine. ठीक है? Have you understood this dm? तो जल्दी कर देता हूं मैं. तो what is the x center of mass? X center of mass का फॉर्मूला इंटीग्रल x dm by इंटीग्रल dm. ओके, x और dm का वैल्यू कितना है? dm is lambda naught by L x dx. Lambda naught by L x dx. Divide by integral dm. What is dm? dm is again lambda naught by L x dx. ठीक है? ऊपर क्या आएगा? ऊपर आएगा lambda naught by L, बाहर आएगा और ऊपर इंटीग्रेशन आएगा x स्क्वायर dx, नीचे भी लैम्डा नॉट बाय एल बाहर आएगा, लेकिन नीचे इंटीग्रेशन आएगा x dx। आर यू गेटिंग दिस एवरीवन? लिखते रहो जल्दी जल्दी, ठीक है, घर पे जाके एक बार देख लेना फिर से, कटेगा कटेगा। ऊपर इंटीग्रेशन आएगा x क्यूब बाई 3, इंटीग्रेशन इज फ्रॉम 0 टू l, 0 टू l, नीचे आएगा x स्क्वायर बाई 2, ठीक है, 0 टू l, 0 टू l, ऊपर आएगा l क्यूब बाई 3, नीचे आएगा l स्क्वायर बाई 2, तो आंसर आएगा l बाई 6। l बाई 6 आएगा क्या? नहीं, 2l बाई 3 आएगा ना। फटाफट कॉपी कर लो। तनिष्का आई गई, आ गई ना, और हर्षित इनको चला गया। ये देख लो, ये इलेक्ट्रोस्टैटिक से क्या है? न्यूटन लॉ, थ्री न्यूटन लॉ। क्या होगा इसको? Resultant force of charged particle A,
दोनों वेक्टर के बीच का एंगल 60 है। ये 3.6 होती है।
एक से कितना आ रहा है? K1 K Q1 Q2 by R square कितना आ रहा है?
3.6
3.6 आ रहा है। 3.6 3.6 और दोनों के बीच में एंगल 60 है क्या? रिजल्ट 0 है ना? हाँ, ये 3 attached to the vertices ना, vertices पे attached है।
हाँ
क्या वो पार्टिकल वहीं पे है कि नहीं? क्या पार्टिकल मूव हो रहा है? ए कहाँ है? वहीं पे है ना। Due to the electrostatic, yes, it is 3.6 like this, 3.6 like this, but this is a rigid rectangle, ये रॉड से अटैच्ड है, रॉड में टेंशन है ना,
ओके
तो ये रॉड भी ऐसे टीटी लगा रहा है।
वो तो बैलेंस हो गया।
हाँ,
मैं ऐसे सोचा so टेंशन
अगर these charges were just kept and then they were asked कि what is the resultant force, then it is 3.6 3.6 due to vector addition. Guys, have you written this? Nothing common sense इसमें, before इसका आंसर 12 by 3 है ना, it is more than L by 2, and by common sense you should understand that the center of mass will lie on this side, right? Okay, okay, now some simple things का center of mass कैसे निकालते हैं देखो, like question, एक question लिखो, consider 3 masses, m1 is equal to 1 kg, m2 is equal to 2 kg, and m3 is equal to 3 kg. चलिए देखो, 3 masses, m1 equal to 1 kg, m2 equal to 2 kg, m3 is equal to 3 kg. Okay, लिख लिया? अब ना एक xy प्लेन बनाओ और वो ना जो पार्टिकल्स है ना वो ऐसे रखें, y एक्सिस x एक्सिस, पार्टिकल इक्विलेटरल ट्रायंगल के उसमें रखें, तो एक रखा है यहाँ पे which is 0,0 और यहाँ पे रखा है 1 kg, ठीक है? थोड़ा सा ढक देना, ठीक है, खिड़की ढक देना, keep the window, close the window and keep the gap like इतना सा, बस इतना सा। डन? Two kg is kept here. Let's say it is at a comma 0, okay, इक्विलेटरल ट्रायंगल का साइड ए है, ठीक है, और यहाँ पे रखा है 2 kg और 3 kg रखा है अगेन इक्विलेटरल ट्रायंगल पे 3 kg, और ये ऐसे, you know, this distance, how much is this distance guys? This red line distance is a, okay, a, this distance also a, एंड यहाँ पे रखा है 3 kg. ओके ठीक है. Right, find the COM of the system. Find the COM of the system. Before finding COM, Vikram, why don't you tell me the coordinate of 3 kg? Yeah, Vikram. Your voice is not audible. Speak something. Hello, say hello, hello.
So can you hear me?
Yeah, I can hear you, but speak loudly and closer to the mic. Your voice is output volume is very low. Yeah.
So will wait. Will be a by 2 comma a.
A by 2 तो सही है. A गलत है. X
एक
को
एक सेकंड y कोऑर्डिनेट गलत है ना.
X को तो A by 2 है.
So is it root 3 a by 2?
It is root 3 A by 2. हाँ, कैसे निकाला बता दो जल्दी.
Sir, you take the right angle. So that it will be whole root a square minus a square by 4.
Correct. This is A by 2, and therefore the vertical length is whole root A square minus A square by 4. Either you can do this, or you can also say this angle is 60 degree. So it is simply A sine 60 degree, which is A root 3 by 2. Okay, the vertical length is A sine 60, the horizontal length is A cos 60. Okay, understood? ठीक है. अब क्या करना है? What is XCOM? बहुत सिंपल है. इसके बाद क्वेश्चन हो गया. X center of mass is m1 x1 plus m2 x2 plus m3 x3. What is m1? इस पहले तो फॉर्मूला लिखो. m2 x2 plus m3 x3 by m1 plus m2 plus m3 और निकालो. जल्दी से लिखो, मैं देखने और भेजो. फाइंड द x सेंटर ऑफ मास. यूज द फॉर्मूला. ये फॉर्मूला लिखो, इसमें करेक्टली वैल्यूज पुट करो. क्या आंसर आ रहा है वो लिखो, निकालो और फोटो खींचे ग्रुप पे भेज दो. बताओ.
Sir, should I send the to you?
ग्रुप में भेजो, ग्रुप में जल्दी. वन टू जीरो प्लस टू इंटू ए प्लस थ्री इंटू ए बाई टू डिवाइड बाय वन प्लस टू प्लस थ्री. जल्दी भेजो धोनी एंड हर्षल एंड विक्रम. 7 ए बाई 12 निकाल रहे थे. 7 ए बाई 12 कितना? 7 ए बाई 12 आया क्या तुम्हारा? डन ओके हर्षल एंड विक्रम एंड मनी क्या कर रहे हो तुम लोग
So also कर दे तो
एक सेकंड, I'm almost done.
वाई भी निकालो वाई सी हाँ वाई भी निकालो बच्चों और वाई का भी फोटो भेजो you have done y no now 1 2 3 1 1 तो क्या होगा 1 1 kg each mass is 1 kg each mass is 1 kg what is the center of mass okay find the y center of mass also it is m1 y1 plus m2 y2 plus m3 y3 and send its photograph
E by 2 comma A by 2
क्या
let's form B by 2
look at it do you find something can you tell me something interesting क्या हो बच्चे क्या आंसर है मतलब अगर y सेंटर ऑफ मास का आंसर क्या है
The root A by 4.
ठीक है और अगर यू नो ठीक है भेज दो मुझे √3/4 तुम्हारा तो आ गया ना ठीक है तुम मुझे बताओ 1 क्या क्या मतलब है जो आंसर आया है 1 उसका क्या मतलब है कहाँ पे है? बताओ बच्चे कहाँ है वो पॉइंट नहीं बता रहे हो सेंटर पे ज्योमेट्रिकल सेंटर एकदम ओके उसको बोलते हैं सेंट्रोइड क्या बोलते हैं लिख लो सेंट्रोइड ओके गाइस नेक्स्ट क्वेश्चन you will do example 6.1 as homework okay fine example 6.1 will be your homework okay now see there is one interesting thing which is given in your book example 6.2 so example 6.1 is a triangle है ठीक है अच्छा by the way what is median of a triangle median of a triangle yes अरे
so
median
that x1 plus x2 plus x3 by 3
अरे median एक लाइन होती है पता नहीं क्या बोल रहे हो median लाइन होती है ना ऐसा नो तो क्या क्यों बोल रहे हैं ऐसे सबकी x1 plus x2 plus x3 by 3 क्या मजा आ रहा है बोलो जल्दी yes median is a line which passes through the vertex and then passes through the midpoint of the opposite side so let's say bc जो साइड है उसका एक मिड पॉइंट होगा ना ठीक है मान लो उसका मिड पॉइंट इज m1 ठीक है तो दिस am1 will be called a am1 क्या है मीडियन फ्रॉम ए समझ में आया वैसे सपोज AC का जो मिड पॉइंट है ना वो क्या है m2 so bm2 will be called मीडियन फ्रॉम बी बी डू यू अंडरस्टैंड दिस ये पता है लिखो जल्दी जल्दी से मीडियन जल्दी लिखो मीडियन फ्रॉम ए ग्रीन लाइन के आगे लिखो मीडियन फ्रॉम ए ब्लू लाइन के आगे लिखो मीडियन फ्रॉम बी जल्दी लिखो जल्दी यानी मीडियन भी नहीं पता 12th में आ गए ठीक है जल्दी करो जल्दी अब देखो लिख लिया ये अब एक फिर से ट्रायंगल बनाओ डिलीट कर दो उसको ट्रायंगल फिर से बनाओ मेक अ ट्रायंगल अगेन हाउ मच हिंदी डू यू अंडरस्टैंड okay then tell me okay you should have told me earlier I'm very English hitting person okay now if you think of these as thin strips you know देखो ऐसे how will you find the center of mass if you divide this triangle into thin strips so let's say there is a thin strip here okay acha by the way a median is the line joining so this median am1 was the line joining sorry this median am1 so forget that I am drawn the median okay forget that that green line is there okay now think of this you know let us divide this triangle into तो ये triangle में this is a strip okay so this is the strip okay of some length इसका जो भी लेंथ है इसका जो स्ट्रिप का मिड सेंटर ऑफ मास कहाँ है m1 मिड पॉइंट पे इसके मिड पॉइंट पे स्ट्रिप के मिड पॉइंट पे which is coincidentally m1 ठीक है again there is I'll take a parallel strip like this उसका मिड पॉइंट कहाँ है उसका मिड पॉइंट is here right if you take another strip उसका मिड पॉइंट कहाँ है ये पॉइंट पे राइट इस पॉइंट पे ठीक है therefore the midpoint of this triangle we can say lies on somewhere this line right because all the midpoints of these are lying on this right so it lies I don't know where but it lies somewhere on this line yes or no understood the center of mass of this triangle lies on somewhere on this line similarly you could have argued if you started your thin strips like this yes or no like this and the next thin strip would be like this right and the next thin strip would be like this and then you would say that your center of mass would lie on bm2 right previously you said the center of mass lies on am1 and now you're saying it is lying also lying on this bm2 and therefore it is lying on intersection of median is called yes write it so the center of mass of a triangular lamina इसको lamina बोलते हैं ठीक है lamina is a fancy term for physics 2D objects okay जो physics में 2D objects होते हैं उनका fancy term है lamina okay तो lamina is triangular lamina का center of mass is always at its centroid okay और ये भी लिखना है intersection of medians is centroid अगर तुमको नहीं पता हो तो ठीक और ये भी लिख लेना कि the coordinate of centroid is always x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3 क्या हुआ हर्षल
Nothing, sir.
क्या centroid ठीक है centroid पे लगता है COM ठीक है, we will do a few questions and then we will center. Actually, one more thing, center of mass, about center of mass interesting is it's very intuitive. Okay, so you need to solve many questions. देखो, suppose you have xy plane and you have a square lamina. Okay, square lamina, and is square lamina, it's a uniform, so everywhere it is mass. Okay, it's a square plate. इसका length है 2a और ये length है 2a. What is the coordinate of center of mass right now? A comma a यहाँ पे है ना, ये सर नो, ये सब में समझ में आया सबको ना guys? Hello, hey, yeah, if you cut out this part of the square from it, which is side a ka square you cut, so these are 4 squares, no? Out of this you cut this square, this is gone. Where will be the center of mass? हाँ, a comma a पे यहाँ पे होगा center of mass, यहाँ पे होगा, नहीं होगा, वहाँ नहीं होगा. It is not at a comma a, no. Good guess, but I don't think so. Question 11. A smooth find out. Find out yourself. Okay, I'm giving you some time. Smooth wedge is fitted in a chamber hanging from a fixed ceiling. Fitted.
So will it be a by 2 comma a by 2?
ऐसा है क्या? I think it's a correct answer also. क्या? निकालता हूँ, रुको 1 मिनट, निकाल रहा हूँ. हाँ? I'm very confused. I'm thinking it is C. सही है. सही है ना फिर? क्यों? क्यों? सोचो.
अगर टाइट रहता सब कुछ,
ये ब्लॉक इस पे ऐसे रखा है ना बी पे, और ये पूरा चेम्बर यहाँ पे टाइट है, तो तोड़ दिया यहाँ से.
चेंबर टाइट है कि
हाँ,
वेज टाइट है?
वेज टाइट थोड़े ना है.
पूरा वेज टाइट.
नहीं, इंग्लिश इंग्लिश. Chamber, the entire chamber is tight.
Okay.
If you break this, this will not go down. Both are falling at the same rate, no? See, ये वेज है,
Yes.
और ये इसके ऊपर ब्लॉक है. हवा में दोनों को छोड़ दिया साथ में, तो ये नीचे नहीं ऐसे नीचे नहीं जाएगा ना फिर. क्यों जाना चाहिए? Tell me one reason.
If it was not cut, so say it is not cut.
कट, वही कट का मतलब है, ये कट यहाँ से छोड़ा ना, ये वाला कट किया ना, which is same as saying इन दोनों को ऐसे छोड़ दिया मैंने, हवा में ऐसे छोड़ दिया. हाँ, फ्री फॉल है, फ्री फॉल स्टार्ट हो गया यहाँ पे. अभी क्यों जाएगा? दोनों तो मतलब सेम ग्रेविटी से नीचे जा रहे हैं ना. If you don't agree to this, think of 2 points. एक पॉइंट यहाँ पर है P, just below, एक पॉइंट just below, above. P पॉइंट का एक्सेलरेशन वो वेज पे है और Q किस पे? ब्लॉक पे है. P पॉइंट का एक्सेलरेशन कितना है? फ्री फॉलिंग. यस. G डाउनवर्ड्स. Q पॉइंट कितना है? G डाउनवर्ड्स. दोनों तो G डाउनवर्ड से नीचे जा रहे हैं. There is no relative. ऐसा तो नहीं है कि इस पे स्लाइड करेगा ऐसे. क्या हो गया? Why is it very surprising? What are you thinking? हाँ, मतलब यहाँ पे ऐसा कोई स्ट्रिंग नहीं जिसको काटा है, ऐसा कुछ नहीं है. ये स्ट्रिंग is not connected to either A or B. It is connected to the chamber in which both of these are put. ठीक है. Okay, so how to do this problem is, see, you can break this down, this square lamina, into 4 4 pieces. One piece this, sorry, 3 pieces, one piece this, okay? Yeah, and each piece mass is m, okay? और इस वाले का पहले वाले का जो सेंटर ऑफ मास है, सेंटर ऑफ मास ऑफ द फर्स्ट बॉडी इज एट व्हाट पॉइंट, व्हाट कोऑर्डिनेट? वेरी गुड, a2, 3a/2, yes or no? इसका गुड, और इसका a/2, सॉरी 3a/2, a/2, नो, ठीक है, 3a/2, a/2. Is everyone getting this? Now what you can do is you can take this entire, this is a mass m, right? So its center of mass is where? It is here. So you can take m into, understood, x center of mass. Suppose you are finding x center of mass of this whole 3 block system. पहले वाले block 1, block 2, and block 3. For block 1, what is the mass? M. What उसका x center of mass is a/2. Understood? Plus for block 2, what is the mass? M. And its center of mass is a/2. Plus block 3, mass m. उसका x center of mass 3a/2. Divide by क्या होगा? What is it divided by? M plus m, right? How many times? So 3m. Yes, very good. So ऊपर आएगा half plus half. Oh wow. What about P? What about physics?
Oh, so we came around 11.
M times ऊपर आएगा a/2, ऊपर आएगा ma. 1/2 plus 1/2 plus 3/2 by 3. mm गया, you'll get a. 1 plus 1.5 is 2.5 by 3. 1 3 1 4 1 5 5 by 6 ही आएगा क्या? 5a/6 आएगा क्या? 5a/6 आया ना? 5a/6 आएगा बेटा, नीचे 3 है ना? 5a/6. So 5a/6 ना actually point, it is closer to, it is less than a, just less than a, right? ये point actually यहाँ है, ठीक है? ये center of mass यहाँ होता है. देख लो, मैं diagram पे बना रहा हूँ. तो ठीक है? When you will find for y, you will find it is still 5a/6. It is here, okay? The center of mass. See on the ground.
Very close to the
Edge. It's, yes, it's very close to the yes. Okay, understood. See, you should have see, very simple, there is very simple logic, you can always check. Only if this block was there, center of mass is here, right? If you add this block, the center of mass will shift ऊपर, no, इसके, understood. If you add a third block to the second block, the center of mass will shift to the right. Understood? Okay, so therefore the net motion is on this line, and of course it will not be this, right? Because there is the original. Yes, so it is somewhere here. Okay, center of mass questions you can just directly take mark without calculating, just using. Okay. Was it someone's parent? You have to go home. Okay. Bye bye.